Students, welcome to IIT JEE NEET classes. This is Ashok, chemistry faculty. Today I am going to explain a Re-Neet exam chemistry full paper with explanation. The Re-Neet exam conducted on June 21st, 2026. Now I am going to explain all chemistry questions in this session. Thank you. The question is, consider the following reaction. The first question, consider the following reaction and choose the correct option. They given toluene. It is reacted with chromyl chloride in presence of CH2 solvent, then followed by hydrolysis, then it will give product P. First, we will discuss about what is the product in this reaction. So if you go into that reaction, first of all, this is toluene. When toluene treated with chromyl chloride, that is Ettard reaction, Ettard named reaction, that is, first of all, it is treated with chromyl chloride, CrO2, Cl2 in presence of carbon disulfide. It is given that the product CHOCrOHCl2 twice. So then followed by hydrolysis, so it become aldehyde group. So here each one is bonded with a water molecule. Then one carbon cannot bear two OH groups. Then by heating immediately undergo dehydration, form aldehyde, benzaldehyde. So toluene converted into benzaldehyde. In this is the Ettard reaction. Ettard reaction. In this reaction, we require 2 moles of chromyl chloride. 2 hydrogens are replaces, so that each one is react with 2 moles of water molecule. CHOH will come. Then finally, by dehydration, it will give benzaldehyde is the product. So the options: the compound P is obtained by hydrogenation of benzoyl chloride with palladium on BaSO4. Once we will check that. So here compound P is benzaldehyde. Go to the first option, that is hydrogenation of benzoyl chloride. Benzoyl chloride. This is benzoyl chloride. This is reacted with hydrogen in presence of palladium BaSO4. So in this reaction, this is also Rosenmund reduction reaction. Rosenmund reduction reaction. So that in this Rosenmund reduction reaction, benzoyl chloride can be converted into benzaldehyde. Okay, na? Same before the P also given that benzaldehyde. So that first option is correct one. Then go to that second option. On treating compound P with saturated NaHCO3 solution, brisk effervescence will give. Actually, this benzaldehyde, when react with NaH sodium bicarbonate, no brisk effervescence will form. So this is wrong option. Then compound B can be prepared by treating benzene with benzo anhydrous AlCl3 and C, that is acetyl chloride. That is a Friedel-Crafts acylation reaction. That is option 3. Benzene treated with CH3COCl in presence of anhydrous AlCl3. So this is Friedel-Crafts acylation reaction. We will get acetophenone but not benzaldehyde. So this is also wrong option. On treating with bromine water, compound P gives a white precipitate. No, actually phenol with bromine water, tribromophenol will form, that is white compound. Benzaldehyde with bromine water, actually benzaldehyde group is what? CHO group is electron withdrawing group. To this benzaldehyde, when we added bromine water, bromine will attack only at meta positions. So not possible to form white product. So the correct option is option 1. The next question is the formula of tetraamine aqua chlorido cobalt 3 chloride. So tetraamine, that is NH3 groups, 4 groups are there. Tetraamine and aqua. Aqua means H2O. Water molecule is called aqua. Cobalt 3 chloride. So that tetraamine 4 NH3 and 1 water molecule and cobalt oxygen state is +3. That is tetraamine and also chlorido. Cl minus also is there. So tetraamino chlorido. Tetraamine aqua chlorido cobalt 3 chloride. Tetra aqua amine chlorido cobalt 3 chloride. Here only 2 chlorines are there. So here cobalt charge only +2. But here +3 is there because 3 negative charges are there. Why? Because oxidation state of the cobalt is similar to how many negative charges present in that complex compound. So the correct option is first one. That is CO, NaH3, 4 tetraamine, aqua and chlorido, cobalt 3. That means here this is -1, this is -1. So this is X. This is 2 are neutral ligands. X -1 -2. Total -3 is equal to 0. X is equal to +3. Cobalt oxidation state is +3. Oxidation state is similar to how many negative ions present in that complex compound. So the correct option is option 1. The next question is the lanthanide ion having 4 unpaired electron is. So this is holmium, HO, holmium and neodymium and cerium and terbium. So generally oxidation states and first valence electronic configuration. Holmium is atomic number 67, neodymium is 60 and cerium is 58 and terbium is 65. So here cerium is xenon 4f1 5d1 6s2. Then neodymium is xenon 4f4 6s2. This is valence electronic configuration. Then terbium xenon 4f9 6s2. Then holmium xenon 4f11 6s2. Now go through that holmium +3. Remove 3 electrons. That is xenon. You remove 3 electrons. That is 4f10. Then here neodymium +3. Xenon 4f 3 electrons remove 4f3. Then cerium +3 xenon 4f1. Here terbium +3 xenon 4f8. So they want 4 unpaired electrons. That's why these two are not answers. Then go to these two. So 4f orbital having 7, f orbital having 7 subshells. 1, 2, 3, 4, 5, 6, 7. Each subshell maximum 1 electron. 1, 2, 3, 4, 5, 6, 7, 8. If 8 electrons are there, number of unpaired electrons, how many? Still 6. Here 10 is there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now 4 unpaired electrons are there. N is equal to 4. So 4 unpaired electrons present in holmium. Holmium is the correct answer. The next question is, for an elementary chemical reaction, the Arrhenius plot is given below. They given the relation between L and K versus 1/T. The graph showing negative slope. If the energy of activation is 6.64 kilojoules per mole and R value 8.3 joules per Kelvin per mole, the temperature at which the rate constant become E square minute inverse is. So in this question, first what they given values, energy of activation, that is EA 6.64 kilojoules per mole, then R value 8.3 joules per Kelvin per mole, then K value is equal to E square minute inverse. What is the meaning of that? ln K is equal to 2. Then only this become E square. So here we use Arrhenius equation, that is K is equal to A into E minus EA by RT. Take natural logarithm on both sides, that is ln K is equal to ln A minus EA by RT. So from this plot we know that when 1 by t becomes 0, ln K value is equal to 6. This is 0, this is 6. So the intercept ln A is equal to 6. Then A is equal to e power 6. So here ln K value is 2, ln A value is 6 minus EA by RT. 2 is equal to 6 minus, what is the EA value? 6.64 by 8.3 into T. So here 6 minus 2 is equal to 4 is equal to this kilojoules value converted to joules, that is 6640 by 8.3 into T. So from this T is equal to 6640 into 8.3 into 4. So from that T value is nearly 200 Kelvin. So answer is 200 Kelvin. So from graph also, slope is what? Minus EA by R. When ln K is equal to 2, it corresponds to T is equal to 200 Kelvin. So the answer is 200 Kelvin. Okay. The next question is the green paramagnetic species formed by heating KMnO4 at 513 Kelvin temperature. So here, KMnO4, potassium permanganate, when heated at 513 Kelvin temperature. 513 Kelvin temperature, it will be converted into actually 2 moles of KMnO4 can be converted to potassium manganate K2MnO4 by releasing manganese dioxide plus O2. Permanganate converted into manganate. Here manganese is plus 7 oxidation state. Here manganese is plus 6 oxidation state. Here D value 0. Here D value 1. So we know very well unpaired electron is responsible for paramagnetic behavior. Paramagnetic behavior. So it is, the answer is K2MnO4. So in the next question, statement 1, trans butadiene upon treatment with bromine in CCl4 gives the following product. Statement 2, okay, that is bromine is opposite direction, methyl group is okay. Statement 2, cis butadiene upon treatment with alkaline KMnO4 gives the following product. Okay, once we will go through that reaction. Here trans 2-butene, that is, so methyl group here, H here. First it is treated with bromine. So what happened here? The reaction will happen with bromine. So see, Br methyl group and H, and methyl group and H. The second bromide ion will attack. So here, so opposite to that direction. So here the bromide ion will attack to that carbon, opposite to that. So we will write this. So slightly tilted line, carbon is there, already methyl group is there, and the hydrogen is there. Then bromine, we will write here, bromine, this is bromine. So here already methyl group is there, and hydrogen is there, methyl group is there, and hydrogen is there. Then bromine will attack. This we can write in Newman projection. This is front carbon, this is back carbon. So in that front carbon, this is 1, this is 2. So front carbon as it is, write down methyl group. So here methyl group, hydrogen and bromine. The back carbon will write that bromine, H and Me. So this is the correct representation of this. But they given here bromine is both are opposite, okay. But here methyl groups and hydrogen groups are also present opposite direction. So but this is wrong. Actually trans compound, trans addition, meso product is formed. Meso product is formed. The meso product we can represent like this, not like this. So this is the wrong option. Then go to statement 2, that is a cis-2-butene treated with alkaline KMnO4, hydroxylation takes place. So here cis addition, hydroxylation takes place here. So methyl group is there, and hydrogen is there, and OH will attack. Same like that, methyl group is there here, and hydrogen is there, and OH group present at same side. Cis addition, same side addition takes place. That we will write in Newman projection. This is the first carbon, and this is second carbon, that is OH, Me, H. Then this also same OH, okay na? That is Me and H. By rotate 60 degrees with respect to first carbon, keep constant, that is OH, Me, H. The second one, by rotate 60 degrees, we can get OH here and Me here and H here. So the correct answer is second one is the correct one. So statement 1 is incorrect, statement 2 is correct. The next question is one of the product for the next reaction, that is alkyl cyclohexyl magnesium bromide, that is cyclohexyl prime amine, that is Grignard reagent or MgBr, Grignard reagent treated with primary amine. So here this is acts as a nucleophile, that is N minus and plus. This is proton donor, and this is a proton acceptor. So that, so in that the reaction, so here all H plus RNH MgBr will form. RNH MgBr will form. MgBr, that is magnesium bonded with Br and NHR. So the remaining alkyl group take out that proton. So actually in Grignard reagent, that is MgBr, so this alkyl group is negative. So here NH2 is there, so it will donate electrons to bond with that Grignard reagent compound Mg, that is Br and N H H, and the cyclohexyl ring is there. Here nitrogen getting positive charge, then it will move and it will move, it will take out that proton, so that cyclohexane is form the product. Then remaining is Mg and Br, NH, cyclohexyl ring is present. So the answer is cyclohexane. The next question is, heating NaCl with concentrated sulfuric acid and MnO2 results in oxidation of manganese. Statement 1. Statement 2. Heating NaI with concentrated sulfuric acid and MnO2 results in the reduction of manganese. So first of all, heating NaCl with manganese dioxide in presence of concentrated sulfuric acid. For example, actually this reaction is redox reaction. Both oxidation and reduction takes place. So here first NaCl treated with H2SO4 converted into NaHSO4 plus HCl. Further, this HCl treated with MnO2, it will become MnCl2. For example, 4 moles of HCl converted into 2H2O, it releases chlorine gas. So overall reaction what happened, that is MnO2 converted into MnCl2. So in that overall reaction, NaCl plus MnO2 plus H2SO4 gives rise to MnCl2 and NaHSO4 and become water molecule and chlorine gas. For example, 4 moles of HCl, 4 moles of NaCl and 4 moles of H2SO4. It gives 4 moles of NaHSO4, this one. So in this what happened, manganese here plus 4 oxidation state, here manganese is plus 2 oxidation state. Here manganese undergo reduction. Manganese undergo reduction, not oxidation. Heating NaCl with concentrated sulfuric acid and MnO2 results in oxidation of manganese is wrong. So here NaI treated with concentrated sulfuric acid. For example, NaI treated with MnO2 in presence of sulfuric acid. So NaI converted into I2 vapors and manganese sulfate will form and sodium sulfate will form and it releases water molecule. So by balancing, this is 2NaI and 2H2SO4, then it becomes Na2SO4. Here also manganese plus 4 oxidation state. Here manganese plus 2 oxidation state, because manganese converted to MnSO4. In MnSO4 manganese is plus 2. In MnO2 manganese is plus 4. So plus 4 become plus 2, that is reduction. That is reduction. So that statement 2 is correct. So here statement 1 is wrong, statement 2 is correct. So the next question is correct trend in the electron gain enthalpy. This is a very basic question. So frequently asked question. We know very well in halogens, fluorine, chlorine, bromine, iodine. Electronegativity order is fluorine, chlorine, bromine and iodine, but electron gain enthalpy, that is electron affinity. So here due to small size of fluorine atom, electron repulsions will arise, so that the electron gaining tendency for fluorine is less compared to chlorine, because chlorine somewhat big size compared to fluorine, and vacant orbital also present somewhat, so that chlorine, then fluorine, then bromine, then iodine. So due to small size, fluorine is less electron gain enthalpy compared to chlorine. So that answer is fourth option. The next question is, Given below two statements. Statement 1, FeOX thrice 3 minus is chiral, and trans CrH2O twice OX twice minus is chiral. So if you go through that FeOX thrice, that is FeOX thrice and 3 minus. So here OX is oxalate ion, that is C2O4 2 minus ion. Both sides same type of ligands will approach to that will attack to that iron atom. That is a symmetrical ligand, that is symmetrical bidentate ligand, symmetrical bidentate ligand. So we know very well in MAB thrice and MAA thrice. So here this is unsymmetrical ligand, unsymmetrical bidentate ligand. This is a symmetrical bidentate ligand. So now MAB thrice, unsymmetrical bidentate ligand is there. Do not show optical isomerism. Do not show optical isomerism. Unsymmetrical bidentate ligand. Symmetrical bidentate ligand show optical isomerism. Show optical isomerism. That's why this is symmetrical bidentate ligand. So this is chiral. So shows optical isomerism. Optical isomerism can exhibited by symmetrical bidentate ligands. In statement 2, that is H2O twice OX 2 minus. That is nothing but A2 AA twice compound. So here we have two types of molecule, that is a cis molecule and a trans molecule. So trans molecule can exhibit plane of symmetry. Plane of symmetry. Okay, na? Plane of symmetry is present. Here M octahedral molecule. So here this is one oxalic ion, this is another oxalate ion. So here H2O is there and H2O is there. Plane of symmetry is present. Plane of symmetry is present. So if it is trans, if it is a cis, there is no plane of symmetry. If it is a cis, that is this is OX, okay na, H2O and H2O OX. This is a cis molecule. No plane of symmetry. No plane of symmetry. So this is chiral. Chiral. Any element of symmetry is present, that is achiral. This is achiral because plane of symmetry is present. A plane is passed through the molecule, it can bisect into two equal halves. That is plane of symmetry. So plane of symmetry is present in a trans molecule. Trans molecule is plane of symmetry is present. That's why achiral. So this is trans molecule. This is achiral, not chiral. If it is cis molecule, it is chiral. So that the correct statement is statement 1 is correct, statement 2 is wrong. So the correct option is option 4. So the remaining questions later will explain in next video. So please like and share the video. Share the video. Thank you one and all. Please support my videos. Then I can do more and more videos which is useful to students. Thank you. So please subscribe my YouTube channel and click on bell icon.